Good day, everyone. Welcome to today's mathematics class. In today's class, we are going to solve this question on the board. And it says integrate the x all over sine x multiplying the root of 1 minus x squared. So this question looks complicated, but very easy. It will only take us just 2 steps or 3 steps. We will arrive at the answer. What we are going to use to integrate this is substitution. And before we can do that, we are going to first of all rearrange this question. What we have here, everything here, sine x and this one is denominator. Both of them are denominators. So which means 1 over sine x, 1 over sine x is sitting as saying sine inverse. Okay, so we are going to rewrite this one in place of this, because this is sitting as saying 1 over sine x and also 1 over the square root of 1 minus x squared, then multiplying by dx outside here. So in that case, this will now be rearranged to become sine inverse of x, then all over the root of 1 minus x squared. Then we have our dx. So nothing has changed. What we have here and what we have here is still the same thing. Just have to think very well. Now, we are going to use substitution. We are going to let u equal to sine inverse here. Sine x inverse. So we can say let u or t become the sine inverse of x. Remember, this sine inverse, the derivative of it is for standard. We have for sine, we have for cos, we have for tangent. So they are standard derivatives. So which means du over dx. If you go to your derivative of inverse trigonometry, you will know that what to give us 1 all over the square root of 1 minus what? X squared. So this is the derivative of what? Inverse of what? Sine x. Now from here, we can make either du or dx subject of the formula. Now let us make dx subject of the formula so that we can use it to replace it here. Now, if you cross multiply here, you are going to have du multiplying this one, then equal to dx. So, or see that you just say du is equal to dx multiplying all of them, so that the same thing we have here, 1 all over square root of 1 minus x squared here, we also be multiplying what? Dx. So what we have here is the same thing. Or let me go in a way that you will understand as a learner. Now cross multiply. So dx will multiply 1 to give us equal to du will multiply this one. Will now give us what? The root of 1 minus x squared multiplying du. So now let us go and use this one to replace the x here. So let's go. Now it means this one here becomes u, because we say let u equal to what? Sine inverse of x. So which will now give us u, then all over, we have the root of 1 minus x squared. Now remember, your dx now represents this. Then become multiplying the root of 1 minus x squared, then du. So here, this one, we just cancel out this, so that we can now have the integral of u du. And what is u? Remember, is what? This. But before that, let us integrate this now. If you integrate u, become u raised to power 1 plus 1, then all over 1 plus 1 plus what? C. So that we now have what? U raised to power 2 all over 2, then plus what? C. Remember that your u is equal to sine inverse. What is the sine inverse of what? X? That is u become sine inverse of x, now all squared, all over 2 plus what? C. This is the answer. Very easy as that. Maths not hard, not hard. It's not difficult. It's not as you think. So if you want to follow more, if you want to learn more of the basis of integration, I posted a lot of work on this last year, to the extent that a fan started asking me if I studied just only integration at the university. So if you want to learn more, search through my page. You're going to be seeing the elementary aspect of integration. If you find this class very interesting, help us to share so that other students can learn. Bye.